Hi everyone, and welcome to today's webinar, Simplify Your Migration Planning to AWS while Identifying 30% Savings with TSO Logic. My name is Carmen Puccio, and I'm a Partner Solutions Architect here at AWS, and I will be your speaker and moderator for today's webinar. So today's agenda, we're going to cover migration planning, the challenges and barriers. We're also going to talk about the use cases around it. We are also going to have TSO Logic and Aaron Rollo, the CEO of TSO Logic, do a demo of the product, and then we're going to talk a little bit about the AWS Logic and TSO Logic research and findings. And then, like I said, at the end, we're going to address your questions. So before we get to that, let's talk about what sets AWS apart. First and foremost, customers have selected AWS for years because we've proven ourselves committed to our customer success, or as we call it, our customer obsession. Here at AWS, we start with our customers first, and then we work backwards from there. And when you look at our roadmap, it's really amazing that roughly 90 to 95% of our roadmap is driven by what our customers tell us. You see the 6 factors listed in front of you, but I just want to touch on a couple. So when it comes to service, breadth, and depth, AWS has significantly more functionality than any other cloud provider by a large amount. We have many more services and many more features within those services. For example, in compute, we have 11 different instance families, multiple options for storage and database workloads, and that's really just the beginning. And when it comes to figuring out which compute instance best fits your workload as part of your migration, tools like TSO Logic are really going to help you make an educated decision which instance size best fits your workload as part of your migration. When it comes to our pricing philosophy, we've lowered our prices on 62 different occasions in the last 8 years, and that's largely in the absence of any competitive pressure to do so. And that's because we tend to be a company that focuses on what customers want. And when it comes to ecosystem, AWS has a rapidly growing partner ecosystem made up of 2 main categories, the independent software vendors and the systems integrators. When it comes to the ISVs like TSO Logic, we have the AWS Marketplace, which is a managed and curated software catalog with an e-commerce storefront that helps customers innovate faster, reduce costs by making it easy to discover, evaluate, and procure, and immediately deploy their tools for those third-party solutions inside their AWS accounts. So you can give tools like TSO Logic a try with a click of a few buttons. So when it comes to the benefits and the challenges of AWS migration, so our customers are really doing some amazing things, and customers look to AWS for things like agility and the cost savings and elasticity, everything that I mentioned before in the previous slide. And there's some really great examples out there, and just to touch on one is cost effectiveness. When it comes to cost effectiveness, GE Oil and Gas, a major business unit of General Electric, is leading the way in the company's migration to the cloud by moving 500 applications to AWS by the end of 2016. And that project entailed re-examining, in many cases, and eliminating legacy processes and thinking to achieve a 52% decrease in IT costs, which led to a greater speed to market and more agility to compete even better in an industry experiencing immense market changes. They're using numerous different services such as Amazon Aurora, AWS Elastic Beanstalk, and AWS Trusted Advisor. And when it comes to barriers to cloud adoption, you may run into some of these challenges, and to be honest, we see these from time to time, and they're fairly common. When it comes to skeptical stakeholders, customers may have those skeptical stakeholders, but this is where you need to engage those stakeholders within the business to create a really strong business case for cloud adoption. And you want to ensure that it's prioritized and aligned between your organization's strategies and goals, along with the IT department's strategies and goals. In the past, there was a lot of guesswork that came along with IT real estate, with spreadsheets and questionnaires, and that really didn't give enterprises a solid grasp on what they actually had when moving to the cloud in terms of their TCO, or total cost of ownership. Automation and tools like TSO Logic really get rid of that guesswork and gets the enterprise moving with tangible data that's real, that actually informs them on what it's actually going to cost to migrate. Upfront costs is another one. It's important to remember that cloud computing is built around a pay-as-you-go pricing model. And you only pay for what you use, and there are options like in the compute category, like reserved instances or spot instances, that can provide you with a significant discount if your workloads fall into that model. And again, TSO Logic will help you right-size and give you the information that you need that helps you make economic sense of your portfolio. And the last one, something I feel very strongly about, is the lack of cloud expertise. And this is where you really want to have your organization start thinking about the cloud center of excellence, because it's the most important investment an organization can make. And building that team of diverse individuals that are willing to learn are perfect for your cloud center of excellence. And those individuals are the ones that are going to create that next generation culture of experimentation and teach others as they progress through the journey. And one of the key skills that they're going to need to learn is understanding how to right-size their workloads for being moved to the cloud. And a tool that allows you to map the appropriate instance size for your workloads that presents that factual information about utilization to those team members allows them to have confidence in the instance sizes they choose as part of their migration. So you can overcome these barriers with tools like TSO Logic, but also we have the AWS Partner Network. And I feel it's beneficial to talk about the AWS Partner Network because regardless of where you are in your cloud journey, APN partners can help you. And this is one of the reasons we have the Partner Competency Program. And within that, we have the Migration Competency Program, which TSO Logic is a member of. And it's intended to highlight the partners who can help customers migrate their existing workloads to AWS, while helping customers also take advantage of AWS's security and architectural best practices. And it acts as a clear recommendation of tools that drive both consulting partners and customers to migration to success, and is intended to highlight partners who offer a low-risk path to AWS from their current environments. And as a result, the bar for that has actually been set extremely high to admit only partners with a proven track record of success in moving and enabling customers, as well as having the sufficient skilled personnel to perform multiple significant migration projects. So the slide that you're seeing here, we call this the cloud adoption mental model, but it's built from the AWS CAF, or Cloud Adoption Framework, which is a simple and agile process to achieving sustainable business value within AWS cloud services. I could spend an entire session talking about migration process and methodology in the CAF, so I wanted to give you the visual representation of the migration process and how it's broken up into phases and how tools help you throughout your journey. And when it comes to tools like TSO Logic, you really want to insert them very early as part of this phase or this phased approach, this opportunity evaluation where you're trying to figure out what it's actually going to take to migrate my workloads to AWS. It's really going to tie into the discovery phase so you can actually show what you have in your data center, help you build out a project plan, and drive towards a right-sized TCO of what it's going to look like in the future state. And last but not least, the AWS Core Migration Services. So we're constantly evolving our services while trying to make it easier for our customers to migrate workloads to the cloud. And regardless of whether a customer is trying to move their servers, their databases, or data to the cloud, the services and tools that help with the migration all share a common goal, and that's to facilitate a migration to AWS by minimizing downtime and application workload impact, and trying to minimize data loss. And with that, I'm going to hand it over to Aaron Rollo from TSO Logic, so he can talk a little bit about his platform and give us a demo.
Thanks so much, Carmen, and thank you all for attending. TSO Logic has been working with AWS for the last year to year and a half. We've achieved the top level of AWS Migration Competency Partnership, and we're really excited to be with you all today and taking you through a little bit of our offering. So we're going to talk today about migration planning and how using data-driven decisions can really drive down the costs and provide true visibility into the migration plan and the migration planning process. So as Carmen mentioned, there's a number of challenges that come up while we're working through cloud planning. Some of those challenges relate to identifying how much compute actually exists inside the enterprise environment. As our data centers have grown over the years, sometimes through acquisition, sometimes they've grown just organically or naturally, we've often deployed compute, deployed physical and virtual servers, and really not kept track of what those servers are doing, how many VMs or physicals there are, and that data becomes critical for getting to the next phase. So one of the challenges is, how do I quickly discover all the things that I have so that I can effectively plan? And once I understand what we have, how do we understand the best AWS instance size and cost to do the job. That's further compounded by what's both a pro and a con, which is the expansion of the AWS catalog, right? Infinite choice in offering from the AWS catalog allows you to really thin slice, but it also makes the selection that much more critical because you don't want to pay for more than what you need. And what this ultimately ties down to is one of the challenges is what's it going to cost? How do I determine the cost of operating inside the cloud as I move from my current state, which may be somewhat understood, to a future state, which is going to be new. With all these challenges, what that often leads to is getting stuck inside the planning cycle. Sometimes we refer to it as analysis paralysis. There's so much information, so much choice, that it becomes difficult to move forward. And if you're not making factual and database decisions, you end up guessing, which could lead to an increased perception of expense. It also leads to increased frustration and certainly increased risk. To overcome some of these challenges, TSO Logic has created a platform that uses analytics and algorithmic-based decisions. We do automated discovery of all the compute inside the environment, which gives real data about your physical servers, about your virtualized servers, and most importantly, how these servers are being used, all backed with real data that allows us to identify how much over-provisioning exists inside the current environment so that we can reduce it as we begin equating it with the thin slices available of compute from the AWS catalog. When you begin to put these pieces together, it drives to a minimum cost reduction of about 30%. And we'll share some additional details on that toward the end here. And ultimately, what the platform is going to provide is not only the most cost-optimized way to run your workloads inside of AWS, but also faster and more accurate planning with reduced time and effort on the part of the enterprise clients. As I mentioned, fundamentally what the platform is offering is an analytics engine that uses data that we've ingested from across your enterprise environment and then analyzing that data with algorithms that we've worked on very closely with both the Amazon Web Services team and also with Intel, who provides the compute processing capabilities across all of these environments. By working closely with these two partners, we're able to do things like equate current generations of processors running inside of the data centers with the newest processors that are available behind the AWS instances. By doing this using algorithms, we can process hundreds of thousands of potential combinations per second so that we're able to always take the data from how your compute is being used today and equate it to what it would look like in cost inside of AWS. And since we can do this on an ongoing basis, as your applications change, as the application use profiles changes, you're always getting an up-to-date and accurate right-sizing recommendation for what it would cost and what instance sizes you would need. And doing this in a manner that's fast, accurate, and easy so that there's no questionnaires, no guessworks, and you very quickly get to a directional forecast of cloud. As an example of this, I'd like to share a use case that we recently completed with Morningstar Financial. Morningstar had a couple of challenges while they went into their cloud planning process. One of the things that they knew for sure is that they had several data centers that were coming up on end of life, and that they were either going to have to move in to new data centers of their own, a co-location facility, or make a move to cloud. Their executive team early on decided that if the economics of cloud were beneficial, that would be their preferred approach. But of course, there was a lot to do to prove that the economics would in fact be more beneficial and to get them started off on the migration planning process. They had a compute and storage footprint that grew over time. There were multiple data centers across multiple geographies in Australia, in the US, and in other countries. And they didn't have a great understanding of what they had across those geographies. There's pockets of information. There were different tools that they were using to keep track of things, but no one place to go to really understand how many VMs they had, and more important, how they were being used. This was further compounded by the fact that they had lots of different hardware, different generations of compute, different generations of storage, right? All of which had to be normalized and understood so that they could create their path forward to choose the best AWS instance size and the cost. So TSO Logic was selected. We used the platform. The platform was implemented in roughly 5 hours, was about the implementation time. By talking to their VMware-based environment, By talking to their Hyper-V-based environment, we were able to discover all their VMs very quickly. They were also using some application discovery mapping tools from Risk Networks, and we were able to ingest data from Risk to further pull in application data. And then they also had a bunch of bare metal machines using things like SNMP and WMI, some older equipment, non-virtualized, that we were able to pull in. By collecting data from all of those servers, physical and virtual, as well as the attached storage, we were able to profile the compute usage and utilization levels. The algorithms then chose the best AWS instance size and the cost running to support that compute. As their workload patterns changed, as they went through month end, we began to get a sense for the elasticity of their environment. When did it need to scale up? When could it scale back down? And all of that was then factored in to find the most cost-effective workloads to move to AWS and when, which ultimately created the business case and the cost savings associated with it that kicked off their planning process. So what I'd like to do now is provide a short demonstration of the TSO Logic Platform. It's not a customer-specific presentation, so we're always careful. We're not sharing any real customer data here, but we will share a demonstration of the platform that looks just like a real live environment. We've just changed some of the names and numbers to protect any confidentiality. So when the platform is first instantiated, the very first thing that we do is set up data collection. And we do data collection by ingesting data from sources where it already exists. So there's no agents that have to be deployed to every individual VM or every individual server. It's simply a collector that pulls in data from different sources, as I mentioned, like VMware's vSphere or Microsoft's Hyper-V. If they're already using and have compute running inside of the AWS cloud, we can pull that data in as well. And what the platform does, once it has all this data in, we connect all that data together so that we can begin driving and making actionable and intelligent decisions. So the first thing that you'll see is on the left-hand side, we've created a topology that shows the different grouped business functions of that compute. So here, for example, we're looking at their production environment. We see that there's 620 OS instances running inside that environment with 64 terabytes of disk. And it's costing about $811,000 per year to operate that compute on premise. All of this pricing data we've applied based on the configurations of the hardware that were discovered running on premise, using a TSO Logic benchmark library of costs. Now, if the client has actual financial data stored for the different configurations of compute, we can apply that customer's cost information directly to the environment as well. But in most cases, for a starting point, we'll use our benchmark catalog of compute. So if we discover that they've got a Cisco server that's 4 years old with this much RAM and this much processing capability and this much storage attached, we know roughly how much that costs from within our benchmark library. We'll apply that cost to come up with a directional idea as to what it's costing to operate this compute on premise. From there, what we do is we can dive into the details of that compute. So here what we can see is a statistical model that we've created for every instance running inside the production environment. We can see the name of the instance. We can see the type of compute provisioned to support that instance. So for example, with the top device 382, we can see it's a dual-core Intel processor. We know now that it's in use about 4% of the time. And when it is used, we can see the average utilization and the peak utilization of that compute. And then the same thing on the memory side. We also know that it's running Windows, and we know the approximate cost to operate that instance on premise today. This becomes critical because it's all of this foundational data for every one of these instances that helps us determine what the best future state fit is going to be inside the AWS catalog. So from here, we can go in and create a new scenario. So we'll choose the Amazon scenario. We'll give it a name. We're going to model this for a 3-year model. We pick the region that we're going to operate it in. And we can also begin to make some other selections here. We can choose how we want to scale, if we want to scale our compute or our memory? Do we want to assume that the utilization of this compute is going to go up, or do you want to assume it's going to go down, or do we want to make an assumption that the utilization is going to be as it has historically been? So we can adjust a couple of these different parameters based on the scenario that we're creating. And then the algorithms go through and make the selection for which AWS instances it would need. And we could see here that as we select the instance sizes, we can then go in and get all of the details about the instances that were selected. Right, so here we can see for a specific instance size, we would need an M4 large. We know the cost of that instance, and any of these could go through and be manually changed if there's any specific domain expertise to be applied. You'll also notice that we've highlighted two scenarios. We've highlighted both the direct match as well as what's called a right size match. And what this is doing is articulating the amount of over-provisioning that potentially exists inside the environment. So we've already noted that the cost of operating this compute on-premise is about $4 million per year. And we know that the cost of operating this at AWS, if we right-size it, is going to be driven down to about 1.8. By doing that, we're also able to see what it would look like if we were to provision inside of the AWS cloud exactly what's provisioned on-premise. So if we were to select the instance size at AWS that exactly matched the instance size running on-premise, in most cases it's actually going to cost us a little bit more because we're not taking advantage of the elasticity or the thin slicing of cloud. By selecting the right instance size for the job, that's where we really get the cost savings and the optimization opportunities, because the beauty of cloud is with so many choices, you don't have to over-provision. You can always pick exactly for what you need and pay for what you need. So we'll go through here and create a couple of different scenarios. And then what we can do is create a multi-year cash flow forecast. So what we're able to see here is what this looks like running over multiple years, running in AWS, along with the associated cost delta over on-premise costs. Right? So we can see the total savings over time versus what it is on-premise. And then we can begin to layer in additional cost factors such as migration expenses or any types of partner programs that might be available to offset some of those upfront migration costs. All of that can be factored in to the multi-year cost model that can then be dropped into your presentations for planning purposes. The other nice thing about this is once these models are created, anything that you click on inside of these topologies, it automatically refreshes. So now you can view your cost of cloud for a specific environment, like production, or you can drill down to a specific application or department, such as the accounting 2 department. And as you're moving through the different topologies, it's always refreshing in real time. So that concludes the demo portion. And now what we'd like to do is take you through some of the research that we've put together based on our experience running across multiple environments. So I'm going to turn it back over to Carmen, who will share with us some of the details around the research.
Yeah, thanks, Aaron. So what you're seeing here, over the past couple of months, 6 customers used TSO Logic while planning out their large-scale data center migration to AWS. And they needed to do a deep discovery to get an idea of the size of their existing environments, but they also needed to analyze the utilization patterns, like Aaron was talking about before. And the outcome was a data-driven business plan and cost model for cloud to fast-track that transformation. It's information like this that really helps those key players, like I mentioned in the CCOE earlier, make that educated decision as part of their cloud transformation and migration journey. And when it comes to the raw numbers for those 6 customers, which you're looking at here is an aggregate across those 6, 33,936 on-premises operating systems were evaluated, which equaled a $58 million plus yearly on-premises cost. And after using TSO Logic and showing that right size model, the cost model showed a drop to $42.8 million a year, which equaled a 26% savings over their on-premises costs. Again, this is an average savings across all 6 clients. In the research, 26% was the average, but Aaron can talk about it some more, but certain workloads actually topped out with over 60% savings.
Yeah, so as we dove into these different accounts, we realized that there were a lot of synergies between them, and we began to aggregate the data up, as Carmen mentioned. And through doing that, one of the things that we found was that when we looked at every single workload, all of the compute deployed within a single enterprise, all of it combined drove down to a savings of about 26%, but that included certain workloads that were going to be more cost-effective currently to operate on-premise, maybe due to utilization characteristics or potentially due to the size of the instances or compute that was provisioned and available. So when we go in and we start looking at the averages of 26%, we found that certain workloads would actually save significantly more. There were a few other key insights that flushed out of the analysis. The first insight is that when cost modeling to AWS, it's not a one-and-done exercise. What we found is that over time, as compute and compute utilization patterns changed, it would impact what the best instance size for the job would be and the cost of those instances. The other thing, as Carmen mentioned, there have been over 62 cost reductions from the AWS catalog over the last few years. There's new instance families that are always being added. There's new services that are being added. So by constantly looking at how I'm utilizing my compute today, whether it's on-premise or already running in the cloud, and comparing that to what's available from those AWS catalogs, you can always identify and ensure that your workloads are running in the right place at the right time and fully understanding the financial implications of any of those changes. So one of the key insights that we found is, you can't just look at it once, put a stamp on this in Microsoft Excel and say, yeah, this is what cloud is going to cost, because so many factors can change both on the application side that you're delivering as well as on the capabilities of the future state environment, such as the AWS catalog. The other big key insight was around over-provisioning. The tendency for the enterprise has typically been to pre-buy compute several years in advance. Very common practice. Makes all the sense in the world when you don't have the elasticity of a cloud catalog to work with. What this led to, though, was purchasing compute so far in advance that you didn't always know how much compute you needed. How big of a server did you need? How big were the processors? How much RAM? And what this led to was some over-provisioning inside the enterprise that over time became substantial. So when we begin to evaluate for cloud, one of the key learnings is there's really no need to over-provision because you can change instance sizes in that catalog at any time. So you can get what you need to satisfy your current needs and then go up or scale down based on need or demand. The other consideration was that the hardware, the processors, the compute running behind those AWS instances are newer and more powerful than what's running inside the enterprise. So by equating a Generation 3 processor running in a data center today with a Generation 9 processor means that you can do a lot more work with a lot less cost, right? So you get those economies of scale. And once those are taken into consideration, you can really begin to understand the cost models, the provisioning, and the utilization that you need when running in that future state. And I think one of the things that we've heard consistently from enterprise clients is that their initial analysis of cloud led them to believe it was going to cost more. And that's often because right-sizing, based on the newer and more powerful hardware, by eliminating the over-provisioning, and by including elasticity into those models. If you don't do those things, if those pieces of the puzzle are avoided, it'd be very easy to conclude that cloud might cost more, right? When you right-size, that's the key to an accurate model, and it's also the key to the most cost-effective models to ensuring that you're getting the most bang for your buck for your workloads. And Carmen, just back to you on some of these points.
Yeah, absolutely. So One of the important things to remember, like you mentioned, and one of the key advantages of moving to AWS is the elasticity. And customers used to over-provision, as you said, to make sure they had enough capacity to handle their businesses and operations at that peak level of activity. And now they can provision the number of resources that they actually need, knowing that they can scale up or down to meet the demands of their business. And as you said, it reduces the cost, but it also really improves the ability to meet the user's demand. So again, having that data-driven cost model from a tool like TSO, it's really going to help you come up with that right-sized footprint. And perhaps maybe it's a footprint around understanding what applications you can shut off on the weekends, like dev test workloads or something along those lines. But having that factual information of what's actually being consumed on premises and what it's going to map to in its future state is critical. And you touched on right-sizing, and as I said earlier in the slides, we have 11 different instance families, and options like reserved instances and Spot are there to help save costs for the customers. And you really want to be informed when you right-size for your migration, so you choose the most cost-effective option that fits that workload's need. So once you've moved to the cloud, you can start to explore concepts like auto-scaling to handle that peak demand, or stopping those idle EC2 instances using EC2 scheduler to further save on those costs. But at the end of the day, it's really about being informed by data-driven results. And again, I can't stress it enough, the tools like TSO Logic are going to help inform you as to what you actually need as part of your migration and as part of your next generation AWS environment.
Yeah, some additional findings here while we're back on the slide. Of the study that we completed, as we looked at and aggregated the data from these 38,000 or so instances that we looked at, the cost savings ranged between 26% and 60%, right? So 26% on the average when we looked at everything, but some specific workloads, when right-sized to AWS, would represent a 60% savings over on-premise. The tricky part is sometimes finding and identifying which workloads are going to be most economically viable that maybe don't require replatforming so you can get them there quickly, and then which applications might require some replatforming so you can get them there behind them in a most economical fashion. So there's that, that act of analyzing the compute and understanding and right-sizing really leads into that. The other thing that we found is one of the most economical things to move to cloud is older hardware. So when we looked specifically at 15,000 instances that were running on hardware that was more than 5 years old, we found a 74% cost reduction for migrating those workloads to AWS. There's also an opportunity here to clean up old OSs, right? We didn't actually illustrate it in these numbers, but we found thousands of machines, instances, running older versions of Windows software no longer supported by the provider, right? So by understanding the types of compute, the OSs that they're running, the generation of hardware that's currently running on, you can begin to take thinner slices at the migration plan to identify where you're going to get the best economics for these initial moves, get the plan kicked off, and then feed through the process. And I think Carmen touched on this as well. Across the instances, 2,883 of them were running in test dev environments, right? Sporadic workloads, things that need to be spun up for use, not necessarily for production or ongoing. And by migrating those, you benefit an immediate savings of 42%, right? So, having done and analyzed hundreds of thousands of instances over the past 6 months, we've really focused in on a subset here and said, what's the data telling us so we can share that in a fashion like this? And we'll continue to do these things. We'll continue to issue benchmark reports and findings around cloud migration, the cost of migration, the economic benefits, as we continue on the journey. So there are some additional resources available. Attached to the webinar here are 2 handouts that you can download. One's the case study on Morningstar, and also a larger snapshot of the research that we produce. So we touched on some of the research items today, but we also have the full research document attached here that you can download and read as you see fit. Carmen, anything else on at this point?
No, I think that's it. I think we can actually get to the Q&A, and I just wanted to pause for a second and just apologize to the folks who are attending around the slide share. As I called out earlier in the webinar, we will be sharing these slides out in the next 2 to 3 days over SlideShare, so you can take a look at those slides if you did miss those, or if your view was obscured by the admin menu. So again, our apologies for that. But with that said, I'd like to jump into the Q&A. There's still a little bit of time left, so I'd like to get to as many as possible, and I might summarize some of them because there is a little bit of overlap between topics. So with that said, Aaron, if you're ready, I'm going to fire a couple your way. So the first question inside the Q&A pane is, how long does it take to set up TSO Logic, and how long do you think it takes typically to get good data?
Yeah, that's a great question. So, you know, the setup process itself happens pretty quickly. What's generally required is either a cloud instance that we can use as a data aggregator, or it can be deployed specifically on-premise, living inside the confines of the client data center. So depending on the industry, you know, we've done quite a bit of work in the financial services space. It gets set up fully on-premise. And in other environments, it can be a cloud-based instance. So it's, in either case, the installation is lightweight. And we begin by ingesting data from all of the sources that already exist. So since there's no agent, we can actually complete the setup time in just a couple of hours. Once we begin ingesting the data, we have a directional forecast for how big the environment is, how many instances there are, the memory configurations, the initial benchmarking to and matchmaking to the best instance size inside the cloud catalog. You have all of that after just 24 hours. So that lets you start down with a good directional view into where you're going. It begins to let us start pulling in some business data, whether it's stored in ServiceNow or, you know, in another ITSM system, to begin to layer on some of those business views about the different environments. Again, you know, setup time for that is under an hour. And then after about 7 days of actual data collection, you can start to really identify how those workload patterns change based on the day of the week, over a weekend, and begin to really start creating your forecasts. So it starts very quick. It's incremental, right? It starts very quickly with, after the first 24 hours, you can see something that's meaningful. After about a week, you've got a higher level of confidence. And then in some cases, they'll let data collection run for about 30 days. Before really baking in those plans. But since it's a dynamic platform that's always running, as your applications change and as your usage change, it's always going to be updating those results. So it's important to, you know, think of it as a dynamic and an iterative process, not necessarily a one and done process.
Yeah, that's a great point. The more time you have to discover your data center, the more valuable insights you obviously get, and you account for, you know, those sporadic workloads that, you know, might pop up only once or twice a month on a billing system or something like that. So that's great. So
you know, just to build on that, just a touch, as you come through the planning process and begin going directly into the migration process, right? You want to be doing that with the latest and greatest data driving those decisions, right? So the benefits that you're getting here aren't just cloud planning as a point in time to say, okay, now I understand what my cost is going to be. As you're going through migration, you want to be comparing back and checking against those benchmarks to identify what's changed, right? Some things might cost less and some things might cost more based on the utilization changes and the pattern changes. And having measurement and having validation and having transparency into that lets you move forward with confidence to keep both your technical and your financial stakeholders on board. Because for the financial stakeholders, you know, they're dealing with budgets that are now a little bit more dynamic than they've been in the past. So that transparency becomes a big key.
Yeah, absolutely, absolutely. So another question that's popped in is how do you get the application and business data, and where does the information come from?
Yeah, so the application and business data is often scattered around the enterprise in different tools. Ideally, it's all in one, but often it's in many. We'll take data exports from a CMDB, data exports from an ITSM like ServiceNow, where that data can be ingested. And then the first thing we have to do once that data comes in is we have to connect it with the actual VMs and physical servers that are deployed, and that acts as a bit of a cleaning process. So when the data comes in from application data, maybe it came from a Risk Networks or a New Relic, or data came in from a ServiceNow, we compare that to the data that's ingested through VMware and Hyper-V, and by stitching that data together, we identify where it matches and where it doesn't match. So one thing that'll often happen is a client will think they have, 3,000 virtual machines attached to these applications, and really there's 4,000 VMs out there. So now we have a list of 1,000 VMs that didn't necessarily have an application owner. So now we can begin to clean and iterate on that process with full transparency into where the data connects and where the data doesn't connect. So the data comes from sources where it already exists, and then the algorithms clean it and prepare it for use inside the platform so that you're confident in the outcomes.
Awesome. So another one that's popped up is what happens after you create the business case for migration to AWS? So you have all of this information and you have the business case. So what's next?
So generally what's happened in our experience is the business case has multiple facets, right? The business case has what instance sizes do I need so I can begin taking that data about those instances and begin actually creating and migrating workloads. So from a operational perspective, the next thing that happens is the data flows out of the TSO Logic Platform into a migration partner such as a Cloud Endure or a Racemi, and they can then begin to automatically create and provision and begin moving those workloads into AWS. Behind the scenes, what our software is doing is monitoring what's still on-premise, what it's costing, what's moved, and what it's costing, and tying all of that together so that the operational and the business stakeholders get a good sense for, is the cost what I thought it would be, and if not, why, right? What changed in my workload pattern that made us have to use a larger instance size than we originally thought? What's happened that's allowed us to use a smaller instance size than we originally thought, right? So tying all that together with full transparency and analytics during planning, through migration into operations, becomes highly valuable to the stakeholders, both on the operations side and the finance side.
Yeah, absolutely. And another one, and you briefly touched on this, but how often do you have to or should you collect this type of data and reporting?
Yeah, in our view and in our experience, once you've moved to cloud, or as you're moving to cloud, the change is constant, right? So the analysis has to be done constantly, right? There's always things that are changing both on the target destinations, on the workload side, that require you to continue to run analytics and optimization algorithms across these environments so that you always ensure your workloads are running in the most cost-effective location as possible. And by doing that on an ongoing basis, it acts as a bit of an insurance policy to ensure that you're not spending more than you thought or more than you need to be, and also that you know where all your workloads are. So we really see it as an ongoing part of the migration process through planning, through migration to operations.
Yeah, I couldn't agree more, and that's very much in line with our CAF framework. And I always say that's when the fun begins, right? You've moved the application in its current state, and maybe you have right-sized it, but at the same time, just because it's moved, by no means are you done. That's where you get to further evolve it and treat it like a living creature and actually see it go to the next generation state. So one more that's popped in is about the actual deployment mechanism and deployment model. What happens if a customer isn't using VMware?
Yeah, so VMware, of course, we see a lot of VMware out there in the industry, so it's an easy one to talk about. But we also ingest data from Hyper-V if they're using Hyper-V as a hypervisor, or even KVM. But for even those non-virtualized environments, we see quite a bit of that as well. We grab data from bare metal, non-virtualized hardware, over protocols that are pretty commonly used inside the enterprise, right? So things like SNMP or WMI, a little bit more old school, but there's certainly a lot of that out there. So we're able to ingest that data. And if there already is some tooling inside the enterprise, such as maybe they're using SolarWinds or Datadog to collect some of the information that we need, we can also ingest data from somebody else that's already collected it, right? So our mission when we set out was to not reinvent data collection, but to ingest data from sources where it's already been collected, so that we can really reduce the friction during installation. So when we begin working with a client, our first question is, what are you using today to collect data? Are you using VMware, vSphere, Hyper-V, SNMP, WMI? Tell us what you're using. We'll then ingest that into the analytics engine, connect it together, clean it, normalize it, and use that for the foundation going forward, so that we can do this in a quick and painless process.
Okay. I'm going to summarize this next one because it's been touched on in a couple of different spaces, but perhaps you could talk a little bit more about how you're able to gather the peaks and lows, right? So one of the questions that's come in is, could you use that information to potentially drive auto-scaling decisions, or as I mentioned before, shutting down those dev test workloads on the weekends because you see that they're underutilized or not utilized at all. So maybe you could talk a little bit about how you record those and how you can easily identify them within the platform.
Yeah, that's a great question. Great question. So, I showed briefly during the product demonstration that we create a statistical model that shows how often an OS is used, the type of compute provisioned to support that OS, and the utilization patterns from both a compute and memory standpoint. That data is based on time series data that we have for those instances that goes down fairly granular, right, to the minutes level. So one of the things that we can do is identify the amount of time that an OS is actually in use. So that information will tell us this OS is used 3% of the time, but behind that, when you double click on it, you can actually know the times of day, the days of the week, the when, right? And that's what allows us to provision and identify opportunities for both auto-scaling, but also identify places where things like a T-series can be used, right? Where you're only, the instance is available 24/7, but you're paying for a certain number of hours per day for processing on that instance. So that, that really allows the algorithm to fine-tune itself to say, here's where you can auto-scale, here's where you can use a specific instance size that's most conducive to the workload, and it's all based on real data about how often these instances are really being used.
All right. So another one that came in, it talks about the data collection again, and you talked about being able to pull server-specific data like database types or server types, or using things like WMI. Could you talk a little bit about what happens in the engagements potentially if there's firewalls or blocked ports inside the data center? Like how do you get by that in your world?
Yeah, another great question. So, what often happens is we end up sitting in highly secure environments where we see that, right? Especially as I mentioned in the financial services space, what we'll end up doing is installing the software inside their walls, inside their management network, and that usually has access to the bulk of the machines. So as long as, if they're using, for example, vSphere or Hyper-V, as long as we can authenticate through the vSphere API or the Hyper-V APIs, we can ingest all that data. But as often happens, there's a data center that's disconnected, not on the same management network. So what we'll end up doing is installing data collectors inside of each discrete segment or each discrete environment, and then all of that data becomes stitched back together in a centralized aggregated source, or it can be analyzed independently. So it, depending a little bit on what's in scope for the migration plan, and also depending a little bit on how you're thinking about migration. So as I mentioned in the Morningstar use case, it was targeted based on what was running in a specific data center because that lease was coming up end of life. In other examples, it's a little bit more holistic, where we have to look across 5 or 6 data centers and do the cost modeling and the analysis. And in those cases, if there are firewalls separating those data centers, we'll use those individual collectors to pull the data in and then stitch it up at the end.
Awesome. And one last one, and we talked about the longer you can collect data, obviously the better it is to identify your peaks and valleys and your true utilization. And we talked about how it's a ever-evolving thing, and so once you've actually moved to the cloud and you want to actually still do the deep metrics of what you're actually using and making sure you're right-sized appropriately. But in the typical engagement, the question that came in is, how long does the typical TSO Logic effort with clients typically last, assuming that there's no issues as part of the overall installation or any blockers that we talked about before?
Yeah, our general guideline for the upfront plan, separating that from the ongoing migration, is 4 weeks of data collection. But you begin looking at the data after the first 24 hours and begin refining it incrementally and understanding and seeing how it changes. So what a typical engagement will look like is we'll start with, from a customer request of, hey, help me create my plan to cloud. After about 4 weeks, we have enough data. We have the platform articulating that data. We have the client side understanding what the data means, and then about an additional 2 weeks of client using the platform, AWS using the platform to put a specific lens on it, right? So applying any domain expertise that they might have about the environment, applying any special pricing or programs that are available that client could take advantage of, such as the Windows transfer or some things that are outside of instance size selection that can be modeled. And that whole process, soup to nuts, is about 6 weeks.
Okay, awesome. So with that said, and we're getting towards the top of the hour, I just wanted to thank Aaron for his time and for the fantastic presentation today, and thanks to all the attendees for joining. I do want to call out the TSO Logic Marketplace link that you will get as part of the follow-up. So all the users who have participated in today's webinar will get a follow-up from the TSO Logic platform with a user account to experience TSO Logic. And at the same time, they will obviously get a link to the recording and the SlideShare. And as I mentioned before, I apologize for a little bit of technical difficulties. I'm being told that will be cleaned up as part of the posting. So, again, any questions that we didn't get to today, and I think I got them all, we will be following up with those users directly via email. And I do invite all of you to fill out a satisfaction survey after the end of the webinar. And with that said, unless anybody has any questions, please don't hesitate to reach out. But I wanted to thank you for attending. And Aaron, again, thank you so much for your time. And it's been a pleasure talking to you today.
Great. Well, thanks so much, Carmen. Appreciate your time as well, and for the chance here to get to work with you guys on great projects like this.
All right. Thank you. Thanks all.